This is the last topic for fluid mechanics, chapter 5, fundamentals of fluid flow. So the previous chapter deals only with fluids at rest, in which the only significant property used is weight of the fluid. In this chapter, chapter 5, will deal the fluids in motion, which is based on the following principles. So the first principle would be principle of conservation of mass. Second is the energy principle, the kinetic and potential energies. And lastly, the principle of momentum. So always remember, once I am telling you about the fluid flow, so the connection or the analogy word for that is fluids in motion or in action. So let's proceed to discharge or flow rate, which is with the symbol of Q, capital Q. It is the amount of fluid passing through a section per unit of time. So natay ko klaseng-klaseng mga flow rate. So volume flow rate, mass flow rate, and lastly weight of flow rate or weight flow rate. So sa volume flow rate, ang formula would be Q equals to A times V. Sa mass flow rate, M equals to rho times Q. So balik ta sa flow rate in terms of unit, cubic meter per second. Sa mass flow rate, kilogram per second. And weight flow rate, W, capital W equals to unit weight times Q, wherein ang unit is kilonewton per second. So again, the Q is discharge, wherein ang unit is cubic meter per second. Ang A is the cross-sectional area of flow in cubic or in square meter or square foot. Ang V is the mean velocity of flow in meter per second or foot per second. Ang rho is mass density, wherein ang unit is kilogram per cubic meter. Ang unit weight is, or ang gamma is specific weight or unit weight in newton per cubic meter or pound per cubic foot. Definition of terms. Fluid flow may be steady or unsteady, uniform or non-uniform, continuous, laminar, or turbulent. So later on, you will encounter or know them one by one. So naputay one-dimensional, two-dimensional, or three-dimensional, as well as rotational or rotational, no, or not rotational. So first, the steady flow. Once we said steady flow, this occurs when the discharge Q passing a given cross section. So this is the Q passing a section, barbed na section, no, wherein constant with time. If the flow or Q at the cross-section varies in time, the flow is unsteady. So, kung dili constant ang iyang time sa pag-flow within aning vessel, so tawag siya unsteady. No? Unsteady. Sa uniform flow, this occurs if the steady flow for a given length or reach of a stream, the average velocity of flow is the same at every cross-section. So, kung every cross-section, section 1, section 2, section 3, so same lang po ang time, ang iyang velocity, ang stream niya, ang length, so that is uniform. This usually occurs in a stream with uniform cross-section. Ang isa po ka factor matawag siyang uniform flow if ang section or ang vessel or isa pa siya na part na or cross-section uniform lang, so uniform flow po siya. In stream where the cross-section and velocity changes, the flow is said to be non-uniform. So kung malahi na ang iyang cross-section as well as ang iyang length per section, so non-uniform na siya. So proceed ta sa continuous flow. Ang applicable for this this occur when at any time the discharge Q at every section of stream or conduit is the same So, tawagon siya na to principle of conservation of mass. So, kung same lang dyan na siya na so, continuous flow. Sa iyang pagkakano, similarity, there will be continuity equation. So, ang Q from here sa in, sa section 1, section 2, section 3, so equivalent tanan. Again, ang Q equals to A times B. Cross-sectional area times sa mean velocity. So, posita sa laminar flow. So, the flow is said to be laminar when the path of individual particles do not cross or intersect. The flow is always laminar when the Reynolds number, so, dari na musulod sa Reynolds number wherein RE dapat less than sa 2,100. No? Later on, akong ikuan ang illustration for laminar and turbulent. So, proceed ta sa turbulent. The flow is said to be turbulent when the path of individual particles are irregular and continuously cross each other. Turbulent flow normally occurs when the Reynolds number exceeds 2,100 or sa 4,000. Or most commonly situation is when it exceeds sa 4,000. So this is the Reynolds number apparatus. Kanino? As you can see, anay bottle wherein naka-elevated, bottle with dye, magkag-dye ka ng atong gigamit no, sa floor wax or mga to. Anything na colored. So, ilang experimentation or Reynolds number apparatus, ilang makita, gilay na color ang turbulent. I mean, makuha mo ang turbulent, kaning red, and turbulent means irregular no ang movement and continuously crossing each other. While sa laminar, continuous lang ang iyang flow. And this is the valve. Pwede na to siya i-on, pwede po na to siya i-off. So that's why they have that apparatus. Or makabalo sila na turbulent or laminar ang flow sa isa ka fluid or liquid. So for you to be able to understand more about the topic, so the best way is to show you an example or problem. So the first example is water flows through a 75 millimeter diameter. Again, P is diameter pipe at a velocity of 6 meter per second. So we are asked to find first the volume flow rate in terms of cubic meter per second as well as liter per second. Next, or B, mass flow rate na dapat ang unit is kilogram per second. And lastly, weight flow rate wherein ang unit is Newton per second. Solution. So first, ato sa illustrate no ang pipe. So sa pipe, 75 man daw. 75 mm diameter no ang pipe. So A, volume no or Q. Let's find the Q. Again, Q equals to AV. Again, ang A is in terms of diameter man, so circle. So pi d squared over 4. And ang velocity is given sa ato sa nikwan. So pi, and i-convert na natong 75 to meter. Okay, meter man no. So 75 mm times 1 meter over 1000 mm. So therefore 0.075 meter. So 0.075 meter square times 4. And given man ang velocity, which is 6. So our Q now is 0.027 cubic meter per second. And this is the first answer. And the second answer for A is liter per second ang unit. So, ato siyang i-convert. Always remember, sa 1 cubic meter na ay 1,000 liter. No? 1 cubic meter na ay 1,000 liter. So, the second answer would be, cancel ni. So, 3 times 1, 2, 3. So, 27 liter per second. No? So, proceed ta sa B. Ang B is mass flow rate. So, M equals to rho times Q. As we have known, water ang involved. So, let's use the constant sa water. And it said na kilogram. So, 1,000. Katong 1,000 na constant. So, 1,000 kilogram per cubic meter. Ang Q is, we are asked in terms of second, man. So, it's upon us to use the cubic meter lang kani 0.027 cubic meter per second. Muna ang Q, no? So, our mass now is 27 kilogram per second. So, cancel ang cubic meter. So, C, wherein weight flow rate equals, W equals to unit weight times Q. And we are asked about the Newton per second ang unit. So, let's use 9,810, no? Newton per cubic meter. 8 times na to sa 0.27 cubic meter per second. Cancel ang cubic meter. And now we have the weight flow rate, 264.87 Newton per second. So, these are the answers for example number 1. So, sa first is 0.027 cubic meter per second. Second answer is 27 liter per second. Sa B, ang mass flow rate is 27 kilogram per second. And ang C, weight flow rate is 264.87 Newton per second. So, second example. So, we are asked or we are given with this problem, no? A pipeline consists of successive lengths 300 millimeter, 250 mm, and 200 meter in diameter, with a continuous flow through the pipeline of 0.20 cubic meter per second of water. We are asked to compute the mean velocity in each size of pipe. So first things first, we need to illustrate, no? Since it is based upon sa diameter, so our pipe is varied. So you can use rulers or mga if you have kanang dili ang anak straight na illustration. So this stands as 300 mm diameter. And this stands as 200 mm diameter. And lastly, ang 200, no? So this is 200 mm diameter. So this is the mean velocity for the first diameter, no? Second and third. So A, B, C. Since I have given, and this is, since I have given the continuity equation wherein the Q is equivalent for Q1, Q2, Q sub 2, Q sub 3, wherein it is 0.20 cubic meter per second, right? So from this formula, Q equals to A, V. So Q1, di ba same lang sa Q? So let's proceed na, no? Q equals to A1 times V sub 1. To be able to find the V1, sa to siyang cross multiply. So Q over A sub 1. No? So Q1 pi d squared d sub 1 over 4. So Q is 0.20 over pi times, convert na nato ang 300 mm. So may mo siyang 3.3 meter square over 4. Therefore, our V sub 1 is 2.83 meter per second. V sub 2, so direct na nato, no? Q2 over A2, 0.20, so pi times 0.25 squared over 4. Therefore, our V sub 2 is 4.07 meter per second. V sub 3, Q3 or Q over A3, so 0.20 over pi, 0.2 squared over 4. Therefore, our V sub 3 is 6.37 meter per second. No? So those are the examples for the first topic, ang flow rate. Next is energy and head. The energy possessed by a flowing fluid consists of kinetic and potential energy, may in turn be subdivided into energy due to position and elevation. So above given dito. And energy due to pressure in fluid. The amount of energy per pound or newton of fluid is called head. No? Energy o tanawa. Amount of energy per pound or newton of fluid. So it is head. So kinetic energy, it comes to our mind na ang yung pinaka-definition is ability of the fluid mass to do work by virtue of its velocity. So we have the formula. The formula is 1/2 sa mass times velocity squared, wherein ang mass, again, because it is fluid, so weight over g, or constant ni siya, no, sa gravity or acceleration due to gravity. And to be able to convert this into head, ato siyang i-divide sa W. So therefore, makancel na to ang mga weight. So ang mabilin for kinetic or velocity head is this one, no? So this is the velocity head na. Or gitawag siya kinetic head. Wherein meter ang unit, as you can see, we are doing the formulation sa unit or simplifying the unit. For circular pipe or diameter, the flowing full. So from the velocity head, so V, gigamit atong Q equals to AV, no? Q over A squared over 2G, therefore Q squared over A2, A squared over 2G. And doing this, Q2, Q squared over 2G times pi d squared over 4. D squared pa yun siya. And thinking na we can 16 divided by 2 divided by 8, so cancel, no? So, for circular pipe or diameter D fully of flowing full, so 8Q squared over G pi squared D4 or D to the power 4. So this one. So proceed ta sa elevation energy, or this is potential energy. The energy possessed by fluid by virtue of its position or elevation with respect to datum plane. So wherein elevation energy equals to weight times Z, and ang energy ay divide na to weight, so that may mo siyang head. So therefore our elevation head is Z. Okay, makancel naman ang weight. So this is the illustration. Datum, again, yung reference, and elevation man siya, so Z ang tawag na to. Pressure energy, or under gyapon sa potential energy, no? The equivalent head pressure head for a pressure of P is P over gamma, or unit weight. Hence, the pressure energy is equivalent to pressure energy, no? Weight times pressure over unit weight. So, divide na to ang pressure energy sa weight. We have pressure head. Diba? So, it turns out na atong ang pressure head is P over unit weight. So, this is the illustration. And this is the piezometer. It is a device used to measure, no? Sa mga elevation through pressure. So, let's proceed sa total energy or head, wherein it is denoted as E, capital E. Ang ato ng total energy or head, kinetic energy plus potential energies. So, unsa man ang kinetic energy? Again, kinetic energy is the velocity head only, no? Ang potential energies are elevation head as well as pressure head. So, therefore, our E or total head equals to V squared over 2G plus pressure over unit weight plus Z or elevation head. So, ang illustration kani, datum, and naka-elevated ang vessel with a piezometer, imaginary ba ni siya or in actual. So we can have the measurement V squared over 2G katong sa upper, no? And with the fluid pressure over unit weight, and ang center or section sa pipe is Z from the datum. So I think I've finished the energy and head, no? So proceed ta with the power and efficiency. So power, when we are talking about power, it is the rate at which work is done. For a fluid or unit weight, and moving at a rate of Q with the total energy of E and the power in joule per second or watts. So the formula here is P, capital P, no? Kaya ang small p is the pressure. So Q, unit weight times total head, ang E. Ang watts, to be able to come up sa watts, again, Newton meter is joule. Man second, so joule per second is watts. Again, Newton meter is joule and joule per second is watts. So ang formula for efficiency equals to output power over input power. I times sa 100%, so we have the value. Ang involved na unit mostly dari is horsepower and watts. So 1 horsepower is 746 watts, or kani siya is SI and this one is English. So 550 foot-pound per square second. So let's have an example, no? if the velocity of flow in 75 meter diameter fire hose is 0.5 meter per second, what is the velocity in a 25 millimeter diameter jet issuing from a nozzle attached at the end of the hose? Compute also the power available in the jet. Again, to be able to solve this, we need to have an illustration. So this is the fire hose. And this is the nozzle. No, nozzle, no, kaning. Again, kita murag S na ning ana. Pasabutan na opening and closing. Opening or an open portion. So this one, gi-indicate man dari sa nozzle na 25 mm diameter. So ning produce siya og, I meaning i-show siya og fluid. So ang center ana is atong datum. Again, the fire hose is this, having a 75 millimeter diameter. And ang kaniya, ang velocity sa hose is 0.5 meter per second, no? And this one is the nozzle. Or simply the issuing jet. And we are asked about the velocity sa jet. Or specifically kanidari, pila man. So from continuity equation, no? Q or flow rate ng hose equals sa flow rate ng jet. 'Di ba? Pila ang flow rate niya Q, same po dari gawas. So area sa hose, again Q equals to AV. Area sa hose times sa velocity sa hose. Ang jet pod, area sa jet, times sa velocity sa jet. And we have the, diba, ang hose having a 75 mm diameter sa 0.075 squared over 4. Ang velocity is 0.5. Ang area sa jet is, namantay 25 mm no, given man. So, pi 0.025 squared over 4 times V jet, V subjet, or jet velocity. So, when we do the cross multiplication, the V subjet equals to, cancel ang pi, ang 4 also. So, we have 0.075 squared times 0.5 over 0.025 squared. So our V-jet now is 4.5 meter per second. So this is the answer, no? Velocity, jet velocity. So we have done power and efficiency. So I think we're ready for Bernoulli's energy equation. So this is the very foundation sa hydraulics, because this is an entry topic, no? Sa chapter 5 is an entry chapter for hydraulics. So partly fluid pa na siya, fluid mechanics. So without further ado, let's start sa Bernoulli's energy equation. The Bernoulli's energy theorem results from the application of principles of conservative energy. The equation may summarize as follows. So through this illustration, we can have our equation. As you can see, no Q and section 1 here. And with any given elevated head or elevation head, Z sub 1 for elevation 1, C sub 2 for elevation 2, and same with the Q. So, datum no, yung basihan, reference sa elevation. As you can see, again, E is the head. No? E at. So, E at section plus E added minus E lost or extracted equals to E section 2. Section 1 eh. This would be. So, muna ang iyang kwan, Y. So, because of the iyahang position, no? Energy equation without head loss. No? What if walay head loss? If the fluid experiences no head loss in moving from section 1 to section 2, then the total energy at section 1 must equal to the total energy at section 2. Neglecting head loss in fluid flow, the values we get called ideal or theoretical value. So the illustration is this. Datum, again, section 1, section 2, one pipe na naka-incline. And this is the ma-produce na to ang HGL or hydraulic grade line. Again, this our piezometer. Piezometer niya, PI piezometer. So, from datum to section 1 and section 2, these are the elevation head. Z sub 1 and Z sub 2. Section 1 to the highest point sa HGL or hydraulic grade line, no, sa mga bases. So, this is the pressure head. P sub 1 over unit weight, P sub 2 over unit weight. And head, I mean, katong basehan sa HGL to the atong upper datum, no, or highest or pinakakuha na sa piezometer, wherein V sub 1 squared over 2G, this is the velocity head, and V sub 2 squared over 2G. So therefore, our E or head 1 equals to head sub 2. So kung ato siyang ikuan, i-format the equation. So, V sub 1 squared over 2G plus P sub 1 over gamma plus Z sub 2 equals to V sub squared over 2G, V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2. So, this is now the equation. No? If walay head loss. And also remember na when we assign sections, ang left, no, this is the left one and the right. So section 1 nasa left and sa right is section 2. So proceed ta sa equation with head loss. What if may head loss? Considering head loss, the values that we can attain are called actual values. So, kung walay head loss, ideal or theoretical values lang. If naa, it is actual values. Unsay na doon sa illustration? No? Ang nadungag is the head loss only. And we are here, ang EGL. Na nasa EGL. Kay kulang man ang kuan ni piezometer. So, si EGL ang ningkuan sa datum, upper datum, no? Ang EGL is energy grade line. Again and again, whatever, again, nasa continuity equation no, unsa pa nakadako ang iyang buka and sa endpoint niya is gamay, same na sila of flow rate. Mag-differ lang sila sa velocity. So, mag-form na ta og equation. Head loss. Ang head loss from section 1 to 2 equals to subtraction sa head 1 and head 2. No? So therefore, V sub 1 squared over 2G plus P sub 1 over gamma plus Z1 minus head loss sa section 1 to 2 equals to V squared over 2, V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2. So our equation, no, energy equation with head loss is that V sub 1 squared over 2G plus P sub 1 gamma plus Z sub 1 equals to V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2 plus ato lang gi transfer si head loss, so na positive HL from section 1 to 2. What if ang atong energy equation with pump? So with pump, no? Pump is used basically to increase head. No, increase head, no, ang pump. Usually to raise water from a lower to a higher elevation. The input power or P sub input of the pipe is electrical energy ang magamit kung mag-input tag power. And its output power or P sub output, so flow energy na ito magamit. As you can see no sa illustration. So this is a suction pipe wherein ato ang section 1 na pud ang datum. So kung higop siya tubig no from this certain kanang iyahang buwan tubig no. So moagi siya sa pump and kung through electrical energy, so i-discharge niya. So flow energy na dari. Before sa P or pump, suction pipe pa siya. Discharge pipe na after sa pump. And moagi dari, this one is nag-flow energy na. So from datum to section 2, so Z sub 2. Again, HA is head added or energy added na. E sub 1 plus HA minus HL section 1 to 2 equals to head 2. So our formula now is V sub 1 squared over 2G plus P sub 1 over gamma plus Z sub 1 plus HA equals to V sub 2 squared over 2G plus P sub 1 gamma plus Z sub 2 plus HL section 1 to 2. So our output power of pump, also member of this, is Q gamma times HA or energy added. Now energy equation with turbine or motor or turbine or motor. Turbines or motors extract flow energy to do mechanical works which in turn converted into electrical energy. So these topics no, kay gamit kayo sa kwan pagkuha og electrical energy. So section 1 from this no, maagi dari and with the flow rate iagi nag turbine. And section 2. As you can see, left jud ang section 1, section 2. So, ang equation na na-form is E sub 1 minus HE. HE is energy extracted. Again, HE is energy extracted. Kana nakuha ba? Extract. Nakuha. Minus head loss from section 1 to 2 equals to head sub 2. Or simply, E sub 1 minus E extracted minus E lost equals to E sub 2. So the formula is V sub 1 over 2G plus V sub 1 squared D plus P sub 1 gamma plus Z sub 1 minus HE minus head loss from section 1 to 2, V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2. So our final equation would be this. V sub 1 squared over 2G plus P sub 1 gamma plus Z sub 2 equals to V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2 plus HE plus HL from section 1 to 2. And our input power of turbine or turbine is Q gamma times HE or energy extracted. So for you to be able to understand more about these topics, we should have an illustration example. So example number 4 for chapter 5. A pipe carrying oil of specific gravity 0.877 changes in size from 150 mm at section 1 and 450 at section 2. Section 1 is 3.6 meter below section 2, and the pressure are 90 kilopascal and 60 kilopascal respectively. If the discharge is 150 liter per second, we are asked to determine the direction of flow and the head loss. So ito sa drawingon, this is the best way, Jud. So section 1, ginstruct man niya, na 150. So the best way announce Jud. Again, you are encouraged to use ruler so that matarong og drawing. But if you are able to do food ng ano lang. Straight lines, parallel lines, ano. And this is 150 mm. Ang P sub 1 is 90 kilopascal. Aning dako man siya. So, nang ani. So, as you can see, dari ang kanang medyo ning kuan ang iyang ikon sa S, ang ning bali. To show an opening, So, 450 dari, mm, theta, and section 1, section 2. So, ang P sub 2 now is, di ba given man 60 kilopascal. So, section 1, dari dyan ang datum. Indicate mo niya, section 1 to 2 is 33.6. So, kani is, muna siya ang Z2. 3.6 meter. Ang Z1 is 0. So, from continuity equation, so Q, again, this is the Q, equals to Q1, Q2. Wherein, given mo po ang Q, diba, discharge is 150 liter per second. So, 150 liter per second. So, we convert it. It will become times na to, so that you can understand more. Again, 1,000 liters is 1 cubic meter. So, 0.15 cubic meter per second. So, direction of flow and head loss. So, to be able to solve sa head loss, bisag ang direction sa flow, klaro naman po kayo na it's going up, pero let's check. So, first, sa V sub 1 ta. V sub 1 equals to Q1 over A sub 1. So Q1 and Q sub 2 is 0.15 man. So 0.15 over pi. Gamito na to ang diameter na 150. Convert to meter. So 0.0015 squared over 4. Therefore, our V sub 1 is 8.488 meter per second. V sub 2 is Q sub 2 over A sub 2. Therefore, again, Q sub 1 and Q sub 2 is the same. 0.15 over pi times 450 centimeters sa second diesel or pi. So, 0.45. Namali ko, no? This one is 0.15. This one is 0.55 squared over 4. Therefore, the answer is 0.943 meter per second. So, una to sa A sub 1, no? A sub 1 is V sub 1 squared over 2G plus V sub 1 squared over 2G plus P sub 1 over gamma plus Z sub 1. Again, input the value. So, V sub 1 is 8.488 squared over 2, 9.81. Ang G is 9.81. Plus ang pressure sa section 1 would be 90 over 9.81. And thinking na, again ha, na siya specific gravity, unit weight man, so constant sa water, and specific gravity. 0.877 plus 0. Okay, Z sub 1 is 0. Kaya na dito ang datum. Therefore, A sub 1 is 14.135 meter. So, A sub 2. A sub 2 is V sub 2 squared over 2G plus P sub 2 over gamma plus C sub 2. V sub 2 is 0.943 squared over 2 times 9.81 plus 60 ang pressure, no, over 9.81 times 0.877 plus ang Z sub 2 is 3.6. So our A sub 2 now is 10.619 meter. No, do the math here. Since, so we must conclude, since A sub 1 is greater than A sub 2, the direction of flow is 1, 2, 2. So, dari na ta. So, pag-check na ko, kani ang inyong mga conclusion. So, ano na siya, ang direction sa flow. So, A sub 1, no, include man ang head loss. Again, A sub 1 equals to A sub 2 plus HL from section 1 to 2. Therefore, ang head loss is HL 1 to 2 equals to A sub 1 minus A sub 2, or 14.135 minus 10.619. So our HL 1 to 2 is 3.516 meters. So kani ang answer. Kaning duwa. Since no. So, mana answer. That is the direction and head loss. Direction is going from section 1 to 2. Ang head loss from section 1 to 2 is 3.516 meter. So, example number 5. Second example, no? I mean, fifth example for chapter 5. So, water enters a motor through a 600 mm diameter pipe under a pressure of 14 kilopascal. It lives through 900 millimeter diameter exhaust pipe with a pressure of 4 kilopascal. A vertical distance of 2.5 meters separates the centers of the two pipes at the two pipes. The sections where the pressure are measured. If 500 liters of water pass the motor each second, compute the power supplied to the motor. So power. So involve dari ang power supply. So let's illustrate so that we can solve it. So ingon siya, water exits sa motor through a 600. So ito lang i-draw no, ana. So I find it easy na unahon sa nato ang mga anis. Mo siya guidance, reference. And this is the motor. Opening here, opening here. So ato lang i-taken. So voila. So this is section 1 and here is section 2. This one is 600 mm no diameter, and na siya pressure P sub 1 equals to 14 kilopascal. And kani is 900 millimeter diameter. So basta na ay mga elbow, ato lang po siya yan. So in Q1 equals to Q2. So again, this is the datum now. So natin Z sub 1 is 2.5 as indicated or given. So start to take from continuity equation, wherein Q equals to Q sub 1, Q sub 2. Equal po siya sa 500 liter per second. Convert to cubic meter so that we can use it in our solution. So 1,000 liter, no, 1 cubic meter. Therefore, it is 0.5 cubic meter per second. So from the formula sa motor or turbine, P equals to Q unit weight HE. Using the BEE or Bernoulli's equation, Bernoulli's energy equation, as you can see, it is E sub 1 equals to E sub 2 plus na siya HE, tapos siya head loss 1 to 2. So first, let's solve sa V. V sub 1 equals to Q1 over A sub 1, therefore 0.5 over pi Convert atong 600 sa meter, 0.6 squared over 4. So V sub 1 is 1.768 meter per second. Next is V sub 2. V sub 2 now is Q2 over A2 equals 2.5 over pi times 0.9 kay 900 man or 4. Therefore, our V sub 2 is 0.786 meter per second. So, balik ta sa BEE. So, V squared. No, ang E sub 1 is V sub kanina formula. And as well ang E2 pod kani. So, V sub 1 is 1.768. 1.768 squared over 2G, 9.81. Plus, next is pressure head. Ang pressure head, given man 14. And, ginigit pa na water. So, walay kauban ng specific gravity or simply 1. 14 over 9.81. Ang Z sub 1 is 2.5. And equals to V sub 2. V sub 2 is 0.786 squared over 2 times 9.81 plus ang atong pressure. Ang pressure is 4 over 9.81 9.81 no, and plus HE, since there is no head loss, so 0. And as we do the math, first kani i-calculate ato ng E sub 1 as well ang E sub 2. 0 man pud ang atong Z sub 2. So therefore kani ang E sub 1 is 4.086 equals to 0.439 kani. So plus HE. Therefore our HE now is 3.6 3.647 meter. So, gikan sa katong formula no na P equals to Q unit weight HE, therefore 0.5 times unit weight is 9. Di na tayo magamit o kilo no, so 9,810 times 3.647. So, our power now is 1788.535 watts. Or ato siyang ikilo, so therefore 17.89 kilowatts. So mani ang ipangita. No, ang power. So this is the 6th example for chapter 5. So the pump shown draws under. So the pump must be given by me. So I will be illustrating it to you, no? Mukha na din ko. Yan.
Hindi ko na sa UTI mag-will. Lagak yung storage UTI.
Kung sa first CPI.
Ikaw ba?
Dili ko. Dali man yung UTI. Suki pa niini.
Kana?
Dili man sa back, sa hips man. Dili down to the back of my legs. Yeah. Gawin mo. Nagpahilot ko. Dili mo man. Nabunok. Pag man, pagbasa.
Parang nabunog, ma'am.
Murag. Kaya sakit. Hindi, tungod. Alam mo, nagpahilot ko. Kung sinakuan, padala mo muna.
Parang nakamangin, parang pa. Full body ba? Naubo, bigla lang. So, habol na pagka. Babae ba yung kanya ko naman Maka-request, kung kaya gano'n, babae ang hirap relaxing.
So this is the datum. So the elevation is 0. And Q1, Q2 no. Properties for this one is 500 meter, 200 millimeter. If I'm not mistaken. So elevation sa point A would be 10. Elevation point B is 60. So now balik ta sa question. The pump shown draws water from reservoir A. So sa A is reservoir. Elevation 10 meters and lifts it to reservoir B at elevation 60. Okay. The loss of head from A to 1. Again, this is section 1. A to 1 is 2 times the velocity head in the 200 millimeter pipe. No? Diameter pipe, and the loss head from 2 to B is 10 times the velocity head in 150 millimeter diameter pipe. Determine the rated horsepower of the pump and the pressure heads 1 and 2 in meters. The discharge is 0.03 cubic meter per second. So, duha ang pangitaon. Horsepower and the pressure. So, tulo bali, pressure man sa 1 and 2. So, let's start. Solution. As we have discussed, or I have already given to you the formula no katong horsepower. Para automatic siya from watts to horsepower ng answer. It is asa to ha. Here. So, idiretso na to siya, 746 lang. So, HP would be Q unit weight HA over 746. Di ba? Para diretso HP. And we need to find first the pressures. So, pressure head 1 and 2. So, using the BEE, no, Bernoulli's energy equation from A to B. So, VA squared over 2G plus PA over gamma plus ZA plus H sub A. No? Equals to V sub V squared over 2G plus PB over gamma plus ZB plus head loss A to B. We know the ang head loss is composed sa head loss sa point A to B is additional or addition of the two head loss sa A to A1 plus head loss na given. I mean head loss sa 2 to B. Ang head loss sa head loss sa A to B is katunod. So therefore A1 is A to 1. So B sub 1 squared over 2G. But it is indicated na times 2 man. Tara, 2 times the velocity head. So 2 times 2 na to ni. So therefore 2 times V sub 1 is not given, so V sub 2G. Cancel, therefore V sub 1 squared over G. So ang head loss pod sa 2 to B is times 10 daw sa velocity head. So V sub 2 squared over 2G. So 5 na lang ni. Therefore 5 V sub 2 squared over 2G. No? So from continuity equation, Q sub 1 equals Q sub 2, there, ano siya pala yun, 0.3 cubic meter per second. So V sub 1 equals Q sub 1 over A sub 1. So 0.03 over pi. Ibapan man 200. So 0.2 squared over 4. No? Kaning A sub 1, 200 biya. Ang sunod kay 150. So our V sub 1 is 0.955 meter per second. Ang V sub 2 equals to Q2 over A2. 0.03 over pi times 0.15 squared over 4. Therefore, our V sub 2 is 1.698 meter per second. So, balik ta sa atong gikuan. So, therefore, HL A21 is V sub 1, 0.955 squared over 9.81. No, kani? So, therefore, atong answer is 0.092 meter. Ang HL2 to B is 5 times V sub 2, 1.698 squared over wala naman eh. Wala na 2. 9.81. Therefore, the answer is 1.47 meter. So, therefore, our head loss A to B is 0.092 plus 1.47. It is 1.562 meter. No? So, balik ta sa to ang BEE. Kani. 0 man na to ang sa A kay 0 man. The question is, exposed man siya god. No? Exposed biya. Datum pod. Mupod na siya. 0 plus, again, balik ta dari sa BE. Therefore, 0 plus, ang ato ang pressure head is 0 plus 10. Ang point A no 10 plus na po'y additional na head. Man 0 ato ang B, ano man siya? BB squared over 2 0 siya. Plus 0 plus 60 ang elevation or Z sub B plus head loss na 1.562. So our HA now is, again, HA is energy added or head added. May mo na siyang 51.562 meters. So balik ta sa tong ko ano na HP equals to Q gamma HA over 746. 0.03 times water naman siya. So 9,810 times 51.562 all over 746. So our horsepower now is 20.34 HP. So this is the first answer. Ang second answer kay pressures no. So una to sa at 1. Pressure ani sa 1 and sa 2. So BE, Bernoulli's energy equation from A to 1. So VA squared over 2G plus P sub A over alpha Z sub A equals to V sub 1 squared over 2G plus P sub 1 over gamma plus Z sub 1 plus may head loss HL A to B. I mean A to 1. So again, 0 plus 0 plus ang atong Z sub A or elevation no kay 10 equals 2. Our V sub 1 is, again, V sub 1 is 0.955 squared over 2 times 9.81. Pangitawan mo na itong pressure ani, so P sub 1 over 9.81. No? Plus Z sub 1 is 0, kay dito man ang section 1. Plus head loss na head loss A to 1 is kani 0.092. So doing the math, we can arrive this formula, this answer no. 10 minus ang result ani would be 0.046 minus 0.092. So better relieve pressure head naman. I forget to include no pressure head naman. So whenever dili na ta, no need na to make it no as if lang unit weight siya. So P sub 1 over unit weight equals to 9.862 meter of H2O. Okay, again unit weight man. Ang I mean pressure heads may gipangita dili man pressure, so as is lang na I mean na jud ang gamma sa ubo sa P sub 1. Same po sa P sub 2. So P sub 2 no pressure head. So dari ko nalibog kaya ako siyang gi-pressure kalang pressure head at A. Kani pressure head at 2. So BE from 2 to B. So again, V sub 2 squared over 2G plus P sub 2 gamma plus Z sub 2 equals to V sub B squared over 2G plus P sub B over gamma plus Z sub B. And do we need to include no sa head loss HL 2 to B. So our V sub 2 is 1.698 squared over 2G or 9.81 plus P sub 2 over gamma plus ang C sub 2, 0. Diba? Kaya ang section 2 is under, align siya sa datum. And B sub B, so as I have said, 0 no, kay open. And 0 po dato ang pressure sa P sub B. And our elevation is 60. Head loss is beta 2 to B is 1.47. Right? So P sub 2 over gamma equals to 61 giada ni 61.47 minus kani, this one is 0.147. So P sub 2 over gamma, or the pressure head, is 61.323 meter of H2O. So this is the second answer for pressure heads. No? So that's all our discussion about chapter 5. Hoping that you have learned something from my video. And goodbye and good luck.